Let me share my screen with you all. I think my screen got it to all of you. Right? Like, right? Okay. Let me recheck 1 second. Just a second. And let me check if my screen is visible to you all or not. Okay. Just a second. Just a second. Yeah, my screen is visible to all of you. Let me read the problem statement pretty quickly. The problem statement is due to the bug there are many duplicate folders in a file system. You are given two DRF paths where path of I is an array representing an absolute path to the ith folder in the file system. Okay. For example, 1, 2, 3 files. Okay, represent the path 1, 2, 3. Okay, two folders not necessarily on the same level are identical if they contain the same non-empty set of identical subfolders and underlying subfolder structure. The folder do not need to be at the root level to be identical. If two or more folders are identical, then mark the folder as well as their subfolders as identical. Okay. For example, folder /n/b, the structure below are identical. They as well their subfolders should not be marked. Okay. Why? Because AXY, AZ, BXY, BZ all are same. That's why. However, if the file should also include the path BW, then the folders /A and /B will not be identical. Note that /AX and /BX will still be considered identical. Okay. Okay, great. Let's see. Once all the identical folders and their subfolders have been marked, the file system will delete all of them. The file system only runs the deletion once. Okay, only deletion once. Okay, so any folder that will become identical after the initial deletion are not deleted. Okay. Return the 2D array answer containing the path of remaining folders after deleting all the marked folders. Okay, great. Okay. So path is equal to A C D A B C B D A. Okay. What other things are identical? Here it is coming B and B at the last. So one level above it is also getting deleted. Okay. Great for this. A B. Okay. B B after B. It is not an Y Y. These two are identical. Okay. Great. For this. Okay. It is looking something like tree-like structure, but do we need to use something like to make tree and all? A C D A B C B D. Do I need to make a tree for A and then C, then A B C B D A? Okay, if I use DFS, suppose what I'll do, I'll start from the root. I'll make a tree somehow, and after from the root tree, I'll make a DFS. Okay. If I'll find a duplicate, suppose I'm finding B here, I'm finding B here. But after this, it is not same. So I'll keep continuing. But if it is a root node, then it is identical. So all the trees will be not considered. And after this, like suppose here also W, here also W, WY, WY. If it is identical, then from this, it will be like not considered. Okay, great. So I use run DFS and I'll delete these things. Okay, I'm getting a hold of what I have to do in this question. Like something coming in my mind. Let's try that thing and see if that idea is working or not. The very first step that I have to do is make a tree, right? The very first thing that I have to do is make a tree. So how we are going to make a tree? We will have insert, we will have delete function, we'll also have to search for it, right? And we have to keep up starts with. Okay, no issues. Let's make a try data structure uh, outside this. Okay, I have to again uh, make another class. Class, right? Okay, after making a class try private and keep node star true. Okay. Mm, Also, mm, public. I'll have to initialize few functions like first of all insert and search one. So void insert. Acha, before this, I'll also have to initialize the try part, right? Let's do this. Okay. Ah, uh, try. Mm, is equal to star. Okay. Now, in insert function, do simple operations like okay, node star pti is equal to let's, paths. Okay, so that's paths. We have ptr contains key. I'll initialize this. Also contains key x. If it doesn't contain x, just push it. Okay. So ptr now to push this or to add this node to our tree. How we are going to add it? We will make another function for all these things. Okay. Let's name it add or put uh, x comma, just make a new node for it. Okay. 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 First of all, before writing all these things, uh, let's complete this first. Now, simple ptr is equal to ptr get the next element, right? Okay, and we have to end the ptr. Okay. Okay, let me just initialize all the node that we want. Okay, we want here. I have made a node star, right? So I'll also need a struct node map node for keys. Okay. That is equal to false. Okay. Okay. So for this, I need contains key. I need put. I need get. I need end. Okay. I need four things. What are the things I need? Mm, bool uh, contains key. I'll need a string key. I'll write this function. Then I'll need the put function, void put. In this, I'll need two things: the key and the node. Okay, node star node. Okay, I need two things. Now what? Mm, contains key put. Another is get, right? So void, not void, node star, node star get. Here also I need a key. Okay, node star key, and the last one is I need what I have named it set and right. Okay, void set and okay. Before this, first of all, contains key. I have to return the like if the map that I have named links, is it contain the key or not? So simple, return links of key is greater than zero. That's it. Links dot count of key is greater than zero. That's it. Now I have to put, so just add it into this links of key is equal to links of key is equal to simple. Now to get, just return links of key, create set and simple flag is equal to true. That's it. So insert function is done. Set and get put contain key. Okay. The next one is I'll write as search. Okay. Here also I need few things like okay. I insert all the nodes into my this right. Insert as done. Let's write the function for the search part. Uh, so is the element present or not? That I have to tell, right? Bool search paths, path or paths, doesn't matter. But still, should use this. Okay, simple node star ptr is equal to simple root. Now check for auto x of paths. If not ptr same contains key of x. If this is the case, mm, if it does not contain this, just return false. That this key is not present. That's it. What if it is present? So ptr is equal to just mm, ptr get key, that is x. Okay, and after all these things I have put like added these things, I have to return true because it didn't go into false, right? Or if I cannot find this, I will have to return to rather than returning to. Yeah, this should work. Okay, okay, once again. Now I got my space. I got bool search, I got bool this. Now, okay, let's start writing the date. Actually, before that, I have to also write this like uh, target route just return route. Okay, okay. The main thing now, uh, the main part that we have is how to delete the duplicates before writing anything. Let's initialize try here. Okay, try. Okay, mm, for let's pass insert x. Okay, I inserted all the elements in try. Now what? I have to serialize all the nodes in the tree. Okay, first of all, I have to serialize all the nodes in the given in the tree. So on the map string int hash uh, star duplicate map. Okay, the first one to serialize. The main task is to serialize. How we are going to serialize? For that, we have to make another DFS call, right? So DFS will serialize all the given like all the given nodes in a serialized manner in hash function also and duplicate map function also. Okay, I'm assuming that. So I'm just writing for now. Let's write making DFS call. Okay. Now what? DFS have to call try dot get root comma the first one is hash, second one is duplicate map. Okay. I got the root, I got the hash, I got the map. Let's suppose that I am getting all the elements as serialized because that is going to be the main part of the code. But let's not think of that part. Now what I have to do? Uh, like I would delete all the duplicate functions. Like I have to delete all the duplicate folders from the main tree, right? So let's write it. So delete the nodes of folders. Okay, now we are going to read a vector of vector on our set of okay, for zero I zero count of hash. Okay. Hash. If the count is greater than one, I'll just if count is greater than one, that means it have duplicates, right? So for auto x of duplicate map of serial, we got insert the value of x. Okay. Now after this, what I have to do? I got my duplicate elements. Uh, Now what? Just think right. Mm, okay, let's write our DFS function first of all. Then I'll diagram the code. Then I'll think what I have to do now. Okay, let's not think much for that part. Okay, I will have a string DFS star name, right? Yeah. Or map, and this is going to be hash, comma, and again this is going to be duplicate map. So mm, till now it was simple. मतलब, it was not a big deal. It was just simple making try and all. The main thing is the DFS part. How I'm going to execute the DFS. How I'm going to get the duplicates, right? So um, what I'll do, I'll first of all get the children of all the nodes and I'll sort them. Okay. After sorting, I'll check. I'll just check is the uh, So this before the children's suppose A B is this one can be said. Unlike hate roads. But I cannot think of anything which can help me get the DFS parts. How I write the DFS? That's the main thing I'm thinking of. I call the children's. That is okay. I get all the details. I just sort it. I'll just sort the children's, and then I'll iterate through all the children's. And push back in the duplicate map. If something that has a bracket and a children. Okay, yeah, I can do this. Great. See, I'll make a vector of pair of uh, synchronous two children. Okay, for auto and name comma child node lives. Okay, now and again call this DFS part child comma dash comma bookmark. Great. Now children dot push back this name comma sub part. Great. After coming out of this loop, I will just sort this. Sort begin comma children. Okay. Now string serial is equal to this. Ah, the main thing is I'll again iterate through name comma child. Okay, you can say name comma sub of children. Okay, SIRENRIL serial plus is equal to name plus this bracket plus uh, the subpart plus the closing bracket. Okay, I did this. Now hash has serial plus duplicate now serial dot push back again. Serial. Okay, I got my DFS part. I segregated my hash and duplicate. Great, but I will also need a different DFS, which I'll keep the name uh, void final DFS. Let's suppose final DFS. Well, it will also same keep the same things as input. Okay, but no, we need more thing to segregate this, which is deleted. Okay, I got node. I got hash, but in case of hash, here it is going to be this paths. Okay, we got path. Mm, this is two vector array because I have to update this as an answer. That's why I'm keeping it. Uh, in place of this, I think I this thing. It's like answer. Okay. Okay. So what I will do if the count of the deleted element is greater than one. Okay. Then I'll not do anything. But if the count is not count of a deleted element is not zero, then I'll just push back. Okay, great. For auto and name child links. Great. Okay, name child node links. Uh, as I told, if if deleted the count of child, if it is greater than zero, means I do not do anything. Just continue. Continue. Okay. If not, then just push back part dot push back the name, right? And also answer dot push back this part one. Great. Again, do the final DFS call and do the same thing. Child, comma, part, comma, answer, comma, deleted. Great. Now, mm, path for that. Let's do this. Right. Here, call this finally first call. Call for final DFS. Before that, I have to initialize the path and the answer, right? So, answer now. Final DFS, and this I have pass node which is try try dot get root right, comma. Sorry, I can do this right answer and delete it. Return answer. Okay, let me just recheck the code and see if I'm not leaving anything else. It's a very lengthy code. Before moving any further, let me see if there is any compilation error or not. Let me submit this code and see if this is working or not. But yeah, I knew it. Struck right. Okay. I left the sequence thing. Let me just check it, okay. Uh, for auto links change sub DFS. Should not push back. Num sub sorted serial for auto serial name plus this. Okay. Void final DFS. Let me again check. Not check line by line. Hmm. Count deep. Ah, okay. Anything else? No, I guess. Acha, in this, have I written any? Uh, okay. In this, I haven't written any base case, right? When it is going to be returned. If simple node, if node uh, links dot empty. This is the case. Run this, and here I have this, right? Okay, vector type, vector of string, right? So yeah, vector of string. Sorry, I have so what? Vector of string answer deleted. Vector of string and answer and deleted. No passing argument path. Um, Passing tells. Ah, I think here I have not vector of string path. Really do this. Do I really need to? Ah, yeah. Finally. Okay. It is. It accepted all the test cases. If it is not, let's see. I don't know. If it will not, I will deepen this code also. Yeah, it accepted. The time complexity and space complexity is very much because it's not good the time and space complexity, but no issues. If I'll just talk about the time and space complexity of this whole solution, so the construction of the trie will take approx n into L, and then n is nothing but the number of paths, and L will the number of posters or number of folders, not posters. And I'm using one DFS call to get all the this they get all the nodes. So for DFS, it's like number of nodes. That is the for sure. Also, mm, the number of length of the serialization. So O into n, I guess. Yeah, I guess O into n. But also, yeah, I'm doing sorting also. So n log n, which is going to be, let's say, p for sorting. So it is going to be uh, L n into the length of serialization into p log k, and one for the deleting. So it is going to be O of n. The total time complexity, I guess, it is going to be. Let me just write it here. So total time complexity will be nothing but right here. Okay, let's write the time complexity. Time complexity will be n into the first that um, p log p for the um, sorting part, and uh, n into n is nothing but the length of this length of the number of nodes is n, and uh, for this it is going to be n into l plus uh, n, n into l for making the tree, like For making the tree, it is going to be uh, for making the tree. I will use n into l. That is for sure. For the serialization part, I will have p log p and n and s. So it is going to be n into not p log p, n into log p plus s for serialization. This is going to be overall time complexity. But if I'm going to talk about the space complexity, it is simple of n into s, the length of the serialization, because I'm just taking the worst time space complexity, and I'm leaving those like the depth of the DFS call and recursive calls. I'm not using those things. Worst time complexity, all these. If you want to add that also, so plus O of L, but the overall time complexity is going to be O of n plus s. So yeah, I think this was our answer. Okay, yeah, it was a lengthy answer, but no issues. Really, really solution. Yeah, thank you so much for watching.